Hello guys, this is the third part of this video in which the NEET questions are asked from NCERT textbook class 11 part 2. Now 128th question. A guitar, two strings A and B made of same material are slightly out of tune and produce beats of frequency 6 Hz. When tension in B is slightly decreased, the beat frequency increases to 7 Hz. If the frequency of A is 530 Hz, the original frequency of B. So the question is a bit confusing, but what you have to remember from NCERT is shown. You have to remember that V equal to root T by mu, which is a direct statement. You can also see the speed of transverse waves on a stretched string. Stretched string, I'll take it as stretched strings of the guitar. And also the thing that you must remember is beat frequency is equal to frequency of the first one minus frequency of the second. So whenever two frequencies are heard separately, or when two frequencies combine, they do not produce frequency of either one. They produce a new frequency which we call it as beat frequency, that is the difference between the two. And the difference will always be a positive difference. Frequency cannot be a negative one. So it's going to be a positive difference. So in a guitar, two strings A and B made of same material are slightly out of tune. Produce beats of frequency 6 Hz, meaning beat frequency is 6 Hz. Nu B is equal to, which I mean as beat frequency, nu beat. So it can be nu A minus nu B or nu B minus nu A, because both are possible. If nu A is greater than nu B, the first case. If nu B is greater than nu A, the second case. So you also have to find out which case it is. They produce beat of frequency 6 Hz when tension in B is slightly decreased. So tension in B is slightly decreased. For this I have shown you a relation V equal to root tension upon mu, mass per unit length. We refer it as mu, and T is tension. We also know that V equal to nu times lambda. So nu is proportional to root T. Or with increase in tension, the frequency increases. With decrease in tension, the frequency decreases. Tension in B is slightly decreased, meaning tension is decreased to some extent in B also, so the frequency of B has decreased. When the frequency in B has decreased, the beat frequency increases to 7 Hz. So after decrease in tension or decrease in frequency of B, the beat frequency has increased to 7 Hz. And it is also given that nu A is going to be 530 Hz. The original frequency of B is the question. So it's obviously going to be the first case, because if you have the second case, if you consider the second case, there is actually a decrease in frequency of B. If the frequency of B decreases and frequency of A remaining constant, then the actual beat frequency is going to decrease. But the beat frequency actually increases in this case. So this actual case is this first one, which is nu A minus nu B. So 6 equal to nu A minus nu B. Nu A is given to be 530 Hz minus nu B equal to 6. We're taking nu B to that side and 6 to the RHS, you'll get it as 524 Hz. And next question is also a quite complicated question. The quantities of heat required to raise the temperature of two solid copper spheres of radii R1 and R2 through 1 Kelvin are in the ratio. Again, I have proof for this from NCERT. You could have found this formula on page number 284, S equal to 1 by m del q by del t. I'm going to use this formula, but in a slightly different way. So what we know is specific heat capacity is equal to del q by del t, where del q is the change in heat and del t change in difference upon m. The quantities of heat, that is del q Q1 by del Q2 is going to be the question. To raise the temperature of two solid copper spheres. So two solid copper spheres. Copper is a material of radii R1 and R2. R1 equal to 1.5 R2 through 1 Kelvin. So delta T is going to remain 1 Kelvin for both the cases. Specific heat capacity is going to remain same. Are in the ratio. So del Q1 by del Q2 is the question. They are given the radius of both the spheres. Now the specific heat capacity. Now let me modify this to certain extent. Since we are not given with mass, let us convert in terms of volume, because we know the radius del Q by mass equal to density times volume. Density times volume into del T. Del T, now S is constant, del T is 1 Kelvin both the cases, density of copper is constant, so we can find that del Q is proportional to V. So del Q is proportional to V, or del Q is proportional to 4 by 3 pi R1 cube by 4 by 3 pi R2 cube. Now 4 by 3 4 by 3 pi 4 by 3 pi getting cancelled, and R1 is equal to 1.5 R2 the whole cube by R2 cube. So what we are going to get is 1.5 the whole cube, and 1.5 is nothing but 3 by 2 whole cube, which is 27 upon 8, and that's the answer. So keep watching videos from my channel, and thank you for now.